The apparatus shown in the figure consists of 4 glass columns connected by a horizontal section. The height of the two central sections B and C are 49 centimeter each. Let this height be equal to h. I will write down the value over here. Both the heights are h, okay, which will be equal to 49 centimeter. The two outer columns A and D are open to the atmosphere. A and C are maintained at 95 degrees Celsius. Okay, A and C, this is column B, this is column C, this is column A, this is column D. Okay, so A and C are maintained at 95 degrees Celsius, while the column B and D are maintained at 5 degrees Celsius. Okay, the height of the liquid in A and D measured from the baseline is 52.8. okay, let me write this as h1 for the time being. H1 over here is equal to 52.8 and h2 over here is equal to, this is h2, which is equal to 51 centimeter. Determine the coefficient of the thermal expansion of the liquid. Now there is one line missing. The line should be over here, that the thing should be over here. The assumption is the entire liquid is in equilibrium. Okay, if the entire liquid is in equilibrium, if I consider any cross section of the water over here or any liquid over here, okay, if I consider this cross section, let us say the cross section over here is A. Okay, the over here all the 4 glass tubes have the uniform cross section or the same cross section. Okay, so I can say that, let me call this point as, instead of A, let me call this point as P. Okay, at section P there will be pressure due to this liquid on the left hand side and due to this liquid on the right hand side. Okay, there will be 2 pressures, but since the over here the body is in equilibrium, I can say that pressure at A plus density of liquid from A, that is the density of the liquid at 95 degrees Celsius, into G into H will be, this will be the pressure from the left hand side, and the pressure from the right hand side will be equal to, let me call the pressure over here as P naught. Okay, let me call the pressure at BC section over here, let it be equal to P naught, plus density of the liquid at 5 degrees Celsius into G into H. Let this be equation number 1. Okay, let this be over here equation number 1. Similarly, when I apply a cross section over here, when I take a cross section Q on the right hand side, pressure from C will be equal to the pressure from D. Okay, the total pressure from C will be equal to total pressure from D. So pressure from C over here will be equal to P naught plus density of the liquid at the C column is at 95 degrees Celsius into GH will be equal to pressure from A, pressure from D over here, pressure from D plus rho at 5 degrees Celsius into G into H. Okay, let this be equation number 2. Now I can consider that, the pressure, now since A and D both are open to the atmosphere, the pressure from the liquid on the top will be same on both the liquid. So instead of PD I can write it as PA. So if I rearrange this part, it will be equal to PA plus rho 5 GH will be equal to P naught plus density at 95 degrees Celsius G into H. Let me mark this as equation number 3. Okay, I will subtract 1 and 3. When I subtract 1 and 3, it will be equal to rho into GH. This will be equal to H1, this is H, this is equal to H2. Okay, this is over here is equal to H2. Okay, and this is H. Okay, over here this is equal to H2. So basically it will be equal to rho into 95 GH1 minus, it will be equal to rho 5 G into H2 will be over here equal to density at 5 G into H minus density at 95 G into H. The acceleration due to gravity will get cancelled out everywhere. So density at 95 degrees Celsius into H1. The height H1 is given as 52.8. So this will be equal to 52.8 minus density at 5 degrees Celsius, and the height 2 is given as 51. Okay, this is equal to 51 is equal to rho 5. The central heights are given as, the central height H is given as 49. So it will be equal to 49 minus density at 95 into 49. If I rearrange the term, it will be equal to, if I take this on the right hand side, it will be equal to rho 5 into 100, and if I shift this on the left hand side, it will be equal to rho 95 into over here 101.8. okay, it will be equal to 101.8. so the density at 95 is divided by density at 5, okay, at 5 degrees Celsius will be equal to 100 divided by 101.8. If I want to find out the value of the, we have to find out the value of the coefficient of the thermal expansion of the liquid, that is we have to find out the value of gamma. So gamma over here, if I substitute the density at certain temperature, it will be equal to density at 0 degrees Celsius 1 plus gamma delta T, okay, it will be equal to 1 plus gamma delta T, okay, which we will use it over here, in order to find out the value of the gamma, okay. Over here we will find out the value of the gamma, okay. So now over here I can simply say, if I rearrange this term, delta 5 divided by, over here it will be equal to delta 95, it will be equal to 101.8 divided by 100. So basically if I substitute the value of delta T, I can write delta 95 as delta 5 divided by 1 plus gamma delta T, the change in temperature is 90 degrees Celsius, is equal to 1.01, so this can be written as 1.018, okay. Basically it can be written as 1.018. So 1 plus gamma into 90 will be equal to 1.018, okay. So gamma 90 will be equal to 0.018. So basically the gamma into 90 will be equal to 0.018. So gamma will be equal to 0.018 divided by 90, okay. If I rearrange this term, gamma will be equal to 18 divided by 9 into 10 raised to minus 4. So basically gamma will be equal to 2 into 10 raised to minus 4. This is the coefficient of the volumetric expansion of the liquid.